Welcome back, welcome back, welcome back to Algebra 2, Chapter 5, Section 5 in this book. And today we are talking about completing the square. What does that mean? It sounds like you're just drawing a square and you need to just keep drawing until you got a whole square. But no, what this is sometimes you get a quadratic equation you can't factor. If you think about it, what are the factors of 3? 3 and 1. Can 3 and 1 be added or subtracted to get 10? No. Does that mean there's nothing we can do? No. We can get the answer using our calculator with a quadratic equation program. We can also get the answer using the quadratic equation, but we can't factor it. So this is just another little thing in our tool bag, in our toolbox, that we can pull out and use in math. There's a lot of different ways to do a math problem. I'm just teaching you another one. All right, and I think it's kind of fun. All right, so how it works is, if you can't factor it, then you take the bare number and move it to the other side by doing the opposite. So what's the opposite of minus 3 plus 3? I move it over here. Okay, now I leave a blank here. I'll show you why in a second. Now what you do is you take the b term. Remember that the coefficients, this understood one is a, the second one is b, and the third one here is c. So this is your b term. And I just realized as I wrote that in the last video I called an understood one an imaginary one. I knew I was getting confused in the middle of that. Hopefully you understand it. Look at it all carefully. Sorry about that. Anyway, what happens is my brain will start thinking about the next point that I want to be sure and remember, while my mouth is still making the first point, and I end up saying the wrong thing. Got to slow down. But my camera cuts off after 12 minutes. Pressure. Under pressure. All right, back to this problem. So you look at the b term and you divide it by 2. So positive 10 divided by 2 is plus 5. And you write it here. You write the x here, you draw parentheses, and you put a square up here. Square. Okay, then you take this 5 and you square it and write it here. Plus 25. Now, technically you're supposed to write plus 25 here too, but you will never do anything with that number again. And I'll usually not bother to write it down. But you should, because the reason why you're allowed to write this here is you can do anything you want in math as long as you do it to both sides of the equals. 3 plus 25 is 28, and now we say, why is x not alone? Well, it's got a squared and a 5. We're going to get rid of the squared first by square rootifying it, and what we do to one side, we do to the other. So that frees it from the squared, and we get x plus 5 equals plus or minus the square root of 28. 28 is made out of 2 times 14, and 14 is 2 times 7. So 1 2 gets out, 1 dies, and 7 stays in jail. So the answer, and then we have to get 5 to the other side. Why is x not alone? It's got a plus 5. So I do minus 5 on both sides. Those cancel out, and the answer is negative 5 plus or minus 2 times the square root of 7. Okay, next idea. Okay, here is another one. Notice these are all divisible by 3. So before you do one of these, if there's not nothing here, probably you're going to pull something out. And we pulled out a 3. Because 3 times x squared is 3x squared, 3 times negative 2x is negative 6x, and 3 times 4 is 12. Remember, this 3 goes away, because what we want to get rid of it. Why is it there? It's multiplying, so we divide both sides by 3, and 0 divided by 3 is 0, so it doesn't really change anything. Alright, so now we're going to do, that we've got rid of our 3, we're going to do our completing the square. We want the bare number to move to the other side, so we do minus 4 to both sides. I know it's all crazy. So 0 minus 4 is minus 4, and we leave our little gap there. Now we cut the b term in half and put it here. Negative 2 divided by 2 is negative 1, and now we square it. Negative 1 squared is plus 1, and we write it there, and technically we write it there too. Now notice, we're doing the completing the square triangle. So it makes a triangle. Whoop! The completing the square triangle. I know math jokes are lame, but they're few and far between, and we are obligated to say them when we can. All right, so we completed the square triangle, and now we are in -4 plus 1 is -3. So now we square root of 5 both sides. Freeze this. Uh-oh, I put a plus. That was a minus. That was a minus, yes. So that's a plus. There we go. All right, that frees that. And now we need to square root -3, which you know we can't do. But it'll be plus or minus. We plus 1 to both sides to get rid of that. So x is 1 plus or minus, and you go ahead and pull out the imaginary to get rid of that negative, the square root of 3. And that's the answer. Now, your quadratic equation won't give you that. It will say no real solution. So you need a program that does the quadratic equation that gives you the imaginary answers. And the one I give out to kids is called discrimi. It's for discriminant. You have to put the numbers in twice, the A, B, and C term. The first time it gives you the discriminant. The second time it will give you the answer in imaginary numbers. So you need a program that can do that because you are allowed to use these calculators on the SAT, the ACT, and in college. And you need to have your programs ready to go, batteries in your calculator or it charged, and this can make the difference because when you're sitting there in college and you're taking that test and you do your work and get your answer, it is very nice to be able to sit there and check it. You can't just write the answer down in college, you have to show your work. But it's so valuable to know that you've got the wrong answer and you need to go figure out what you did wrong. I promise you. Okay, you remember how we learned standard form and slope-intercept form and all of that? Well, there is a form called the vertex form that's very easy to get from completing the square. And if you have it, it tells you the vertex of your parabola. So in this form, you've got y by itself. Sometimes you have something pulled out like that 3 over there. And then you have your where you completed the square. And you've got your k, which is something that is not in the square part, okay? So the vertex is the opposite sign of the h and the same side as the k. On a calculator, you can get the vertex off of your graph by doing second trace and selecting maximum or minimum. If the parabola goes up, you need a minimum. If the parabola goes down like a mountain, you need a maximum. So here is an example one that's written in this form. So my vertex is 4, -5. I grabbed just this one to show you. I didn't worry about the 3 up there. But here this is while we were completing the square, we got x minus 1 squared is -3. You can move that -3 back over here, and then that's your h and that's your k. The opposite sign of h is 1, k is 3, so the vertex is 1, 3. Alright, so that is completing the square. I used to think it was not necessary, that it was not very useful, that by this point in our algebra careers we've had so many other ways to solve equations that are better, but I've changed my mind. I've really mellowed out as I've gotten older, and as I have taught math more and tutored kids in college more, I tutor college math. They need it for college, so it's important that you go ahead and get used to it in high school, because I'll tell you a secret. Sometimes in college you get a bad teacher. They're not all jewels. So it's good while you've got time and maybe a good teacher or you can understand it to go ahead and learn it. Alright, so we're not going to hate on completing the square because it's a triangle. Math is great.